All right, let's take a look at the notes for section 4.1. So the first thing in 4.1 is classifying triangles. And we're going to classify triangles both by their angles and by their side lengths. All right, so when we look at this, a lot of these words are from the past. In number 1, we have a triangle that has equal sides. So that is definitely equilateral. So we'll say B. All the angles are less than 90. So we have acute. And if I run through the other options, we've got acute, equal angular. Well, all the angles on this one are the same, so B is good. Obtuse, there's no angles over 90. Right, there's no right angles. Equilateral, all the sides are the same, so we have E there. Isosceles, there are 2 sides congruent, but it's all 3, so we're going to leave that with the classification of equilateral rather than isosceles. And then scalene, all sides are different. So B, A, and E would be our choices for number 1. If I go to number 2, first thing, all those angles are clearly less than 90, so we have an acute triangle. All right, it is not equilateral, equiangular. It is not obtuse. It's definitely not a right triangle. It's not equilateral, but it is isosceles because we have 2 side lengths that are marked the same. All right, if I go to number 3, all the angles are marked at 60. All right, so we are an acute triangle because they're all less than 90. Let's see, equiangular, that is true as well. All right, obtuse, we're not in that category because no angles are over 90. It's not a right triangle. It is equilateral because all the angles are the same, so in turn all the sides are going to be the same on this one. And let's see, we would not classify it as isosceles because it is more than 2. And scalene, we don't have that because all the sides are the same length. All right, if we push down to number 4 here, number 4, we have acute angles, so that's going to be A. All right, it is not equiangular because all the sides aren't the same, so we know all the angles can't be the same. It is not obtuse. None of those angles look bigger than 90. None of those angles look right, so it's not right. It's not equilateral. It's not isosceles, but it is scalene, which is G. All right, if I go to number 5, we can't say acute because there is that 90-degree angle. We can't say equiangular because they are different. It's not obtuse, but it is right, so we'll give a D there. And then in terms of the side lengths, we are looking scalene because all the sides appear to be different lengths. All right, so we are a G on that one. All right, jump into 6 here. 6, we have an obtuse angle in there, so we are C, obtuse triangle. All the sides are marked different lengths, so that is scalene, G, and that rules out the other options. If I go to number 7, this one's kind of sneaky in terms of the angles. So when we look at that, it looks really close. So we look at the 3 squared plus 4 squared, and that's going to be a 9 plus 16, which is 25. All right, that does equal 5 squared. So Pythagorean theorem, all right, would tell us that it is a right triangle. Little tricky, and we're going to talk more about that a little bit later on in the semester, but that one is a right triangle because it does satisfy Pythagorean theorem. With that, it's also scalene because all the sides are a different length, so we'll give G there for that second part. All right, so that takes us to the first page. Big thing, acute triangle, all the angles are less than 90. Equiangular triangle, all the angles are the same size, which means they have to be 60 apiece. Obtuse triangle, there's one angle that's greater than 90. Right triangle, you have one 90-degree angle. And then when we go to classify based on side length, equilateral, all the sides are the same. Isosceles, 2 of the sides are the same. Scalene, none of the sides are the same. All right, so that kind of goes through classifying triangles. If we jump to the next portion of the notes, we've got a couple definitions. All right, and it says draw a picture of triangle JDL. So I'm going to draw a triangle here, give a J, a D, and an L. All right, so the sides on this one are JL, JD, and LD. All right, those are my 3 sides. My vertices are J, L, and D. My angles are angle L, angle J, and angle D. And then the angle opposite side, so angle L is opposite side JD, because notice if you're standing at L and you look out, JD is over on the opposite side. All right, angle D is opposite side LJ. All right, so if I erase that original arrow in there and I go to D, notice if I look out across, we've got JL. And angle J, the one we haven't done yet, is opposite side LD. Now, standard notation that we use is a lot of times what we'll do is we'll label that opposite side with a lowercase letter. So opposite angle D, we would call that side lowercase d. Opposite angle L, we'd call it side lowercase l. And opposite angle J, we'd call it lowercase j. And that's just kind of a shorthand that we use quite often to identify the sides and the angle relationships in a triangle. Now, special names of an isosceles triangle. So certain triangles have special names that we deal with. So in this, it says identify the following. The first one is the vertex angle. All right, that's the angle that connects the two congruent sides. So in this one, that's the B. All right, so that's our vertex angle. The base angles, they're the two that are between the congruent side and the non-congruent side. So base angles would be these two down here, angle A and C. All right, so those are our base angles. The legs are the congruent sides. So in this one, AB and CB. And then the base is the non-congruent side, so AC. All right, so the base is this side. We have the base angles are A and C. That's a leg, and that's a leg. All right, so we have vertex, legs, and bases in an isosceles triangle. And we also have vertex angle and base angles. Now, in a right triangle, we have some special names too. The first one is hypotenuse. All right, that is always the side opposite the right angle. So it's this side over here, which is AC. All right, we also have the right angle, which in this case is angle B. It'll typically be marked for us. And then we have the legs. The legs are the sides that are not the hypotenuse. So in this case, that's AB and BC. All right, and those are some just names that go with certain types of triangles that we have. Now, the two examples down here that will get you ready for tonight's homework. Example 1, an equilateral triangle has the side lengths of d plus 2, 12 minus d, and 4d minus 13. What is the length of each side? So I would always start with a picture. They said equilateral. So we know all the sides are the same length. So we have d plus 2, 12 minus d, and 4d minus 13. Now, if all of these are the same length, we can pick any two of them. I'll pick the top two, and we can set them equal. D plus 2 equals 12 minus d. Add the d over, so 2d plus 2 equals 12. Subtract the 2 over, 2d equals 10, and we get to d equals 5. All right, it said what is the length of the side, though, so we need to take that 5 and plug it back in. And d minus 2, that would be a 7. 12 minus d, that would be a 7 as well. And 4d minus 13 would be a 7 as well. All right, so each side has length 5. All right, and again, that's because we're taking has length 7, my apologies. Because we're taking our 5, we're plugging it in, and we're finding the actual length of the side, which is 7. All right, and then the final example here in the notes, we've got triangle JDL, so I'm going to draw that. All right, so JDL. With sides JD is 2x plus 5. So I'm going to go ahead and label JD 2x plus 5. DL, 3x plus 4. And JL, x plus 6, has a perimeter P equal to 23. All right, what is the length of each side? So perimeter is the sum of all the side lengths. So I'm going to add up all the sides here. And I've got 2x plus 5 plus 3x plus 4 plus x plus 6. All right, so if I combine that, I've got 5, I've got 6 x's, and then 15. All right, and that equals the perimeter, which is 23. So then we'll go ahead, we'll subtract the 15 off each side. All right, that's a 6x equals 8, and x equals 4/3. All right, so we're going to double check that just because it's a non-nice number in a sense. So I've got my 2x plus 3x plus x. That's going to be 6x, so that checks. Got 5 plus 4, which is 9. 9 plus 6, which is going to be, oh, and I did have a mistake there. So we've got the 2x plus 7, and I accidentally wrote a plus 5. So we're going to correct that real quick. So we've got 2x plus 7, and that's going to change this piece here. So rather than rework that work, we're going to come off to the side and try that again. I've got 2x plus 7 plus 3x plus 4 plus x plus 6 equals 23. That's going to be a 6x, and then we've got 7 plus 4, which is 11, plus 6, which is 17, equals 23. If I subtract that 17, I end up at 6x equals 6, and x equals 1, which is a much nicer number. Now, we can't have fraction and decimal and ugly answers, but sometimes when we get those, it's a warning that, let's just double check and see if we did something wrong in there. So I have x equals 1. It asks me what is the length of each side. So I'm going to plug that 1 back in, and we've got JD is going to be 2 times 1 plus 7, which is going to be a 9. Then we have DL. DL is going to be 3x plus 4. So 3 times 1 is 3 plus 4 is 7. And LJ is going to be 1 plus 6 or 7. All right, so in this case, this would be an isosceles triangle. All right, so when we look at this, all right, it asks us to classify the triangle. So we could go back and we could say this one is isosceles because 2 sides are congruent. All right, so that takes us through that set of notes. That should set you up for tonight's homework very well. Again, sorry on the mistake on that last one. It happens to all of us. And when it does, just kind of take a look back and say what thing was off. And we noticed from the original question, we originally had a miscopy right there. All right, thanks. Bye.